Alright, this is the fourth and final part of our review of right triangle trigonometry. In this video we will focus on 45, 45, 90 triangles and 30, 60, 90 triangles, our special right triangles, and the patterns that they have. And at the very end we'll throw in a little bit of conversation about complementary angles and a little theorem involving sine and cosine. Basically, spoiler alert, sine of one angle equals the cosine of the other angle in a right triangle. But we'll take a quick peek at that. Alright, special triangles. First, let's review the rules. Alright, so remember, these are your special right triangles. I think the easier one is the 45, 45, 90 triangle. And because that's an isosceles triangle. So right triangles always have a hypotenuse and two legs. So in a 45, 45, 90 triangle, the two legs are equal because it's isosceles. And then the hypotenuse is a leg times radical 2. So it's like leg, leg, leg radical 2. Okay? So for example, real quick, let's say this was 5. Then it would be 5, and then this side would be 5, and then this side would be 5 radical 2. Okay? Now, similarly for the 30, 60, 90 triangle, I have two legs and a hypotenuse, but it's not isosceles. We have a short leg that's across from the 30, and a long leg across from the 60. Alright, so focus your eyes on the short leg, because that's what we're going to call x. Alright, so notice how the x shows up in all three places. So it's all about the short leg. So if the short leg is 5, then the hypotenuse will be 2 times 5, right, which would be 10. And then the long leg would be 5 radical 3. So it's 5, double 5, 5 radical 3. Okay, so that's how the pattern works. Alright, sometimes we have to work backwards, and we'll look at those in a minute. Alright, but that's the basic idea. Keep that in your head as we do the following problems. Okay, back to work. So look at problem number 11. Alright, you see this is a 45-degree angle, so that means the other angle is automatically 45 degrees. So we have a 45, 45, 90 triangle. And as you saw, the pattern for that was leg, leg, and then the hypotenuse is leg radical 2. But the legs are equal. So here's a leg. So if this is 6, then this must be 6 over here, and then this must be 6 radical 2. Okay, leg, leg, leg radical 2. 6, 6, 6 radical 2. So x equals 6 and y equals 6 radical 2. Alright, x equals 6 and 6 radical 3. No, it should be radical 2. X equals 3, no. X equals 2 radical 3, no. X equals 6 and y equals 6 radical 2. That's it. D is the one that fits the pattern. Okay, let's take a look at number 12. Now, number 12 is a 30, 60, 90 triangle. You see the 60 is given. Alright, but these two angles have to add up to 90 degrees. So if this is 60, the other one has to be 30. Now, so this is another easy one. See how this 9 is across from the 30? Alright, that makes it the short leg. Okay, the short leg, the x is the one that's across from the 30. So that's great, because that's the one we need. Alright, if you have the short leg, the hypotenuse is double that, and the long leg is the short leg times radical 3. Okay, so the short leg is 9. So the hypotenuse should be double that. Okay, so that's why the hypotenuse will be 18. Okay, and then the long leg should be the short leg times radical 3. So this should be 9 radical 3. Okay, so A is 9 radical 3 and B is 18. A is 9 radical 3. Nope. Okay, A is 9 radical 3 and B is 18. There it is. So the answer is C. Okay, so far they've been nice to us. Alright, look at number 13. Again, we have a 30, 60, 90 triangle. Okay, this is the 30 right here. Okay, so which means that this is the 60 up here. Alright, so that's great. This looks good again. Another easy one, because if this is the 30, that means that this 8 is the short leg. Alright, because the short leg is always across from the 30. And it's all about the short leg. If you double it, you should get the hypotenuse. So this should be 16. Alright, so that's n. If you take the short leg and put a radical 3 on it, then you've got the long leg. So this one should be 8 radical 3. Okay, so m, so apparently we're doing m first. So m should be 8 radical 3, and then n should be 16. So nope, nope, nope. Okay, it looks like the last one. M is 8 radical 3, and n is 16. So the answer is E. Okay, these problems have been very, very easy so far. Okay, that was E. That was number 13. Okay. Now, number 14. A 45, 45, 90 triangle. And again, another easy one. Okay, these are all layups, man. This is a 45, 45. Again, this 3 is a leg. Alright, you know, just look at one triangle at a time. Okay, yeah, just focus on the yellow triangle here. That's all we need. So if this is 3, then this is 3, and then this will be 3 radical 2. Alright, because that's the pattern of a 45, 45, 90 triangle. Leg, 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 radical 2. Okay, 3, 3, 3, radical 2. And this is half of a square. So if this is 3 and this is 3, obviously y will also be 3. Alright, so x is 3 radical 2, and y is 3. Alright, well that's A, right off the bat. Okay, I keep saying that this is easy because I kept waiting for them to give us, you know, like a whole number for the hypotenuse, you know, something we're not expecting. So we have to like make an equation and divide like we've seen before. Kind of worried that that's not happening, and all of a sudden it'll be on the test. Alright, because that happens all the time. It'll be not on the review, but then it'll be on the test. Okay, so if it doesn't show up soon, I'm going to just make one up. Okay, here comes one. Finally a challenge. So number 15 is not an easy one. It's not hard, but it just is not so easy. And here's the bottom line. You see we have a 30, 60, 90 triangle. Alright, but this 4 they gave us is not the short leg. Y is the short leg. Okay? So y is the short leg, x is the hypotenuse. This 4 is the long leg. But wait a minute. The long leg is supposed to be something radical 3. X radical 3. Alright, so here's what I have to do. Let me zoom in a little bit more. Okay. I'm going to use a different variable because I've already got an x here. So instead of doing x, 2x, x radical 3, I'll use n since x is already taken. So the short leg, that would be like n. Okay, the hypotenuse would be like 2n. And the long leg here is supposed to be n radical 3. You know what, maybe I'll put it on the left side. Okay, n radical 3. Okay, short leg, hypotenuse, long leg, n, 2n, n radical 3. Now, let's deal with the one number we have, 4. So n radical 3 must equal 4. So what you do is you find n by dividing by radical 3 on both sides. So I will take this and I will divide both sides by radical 3. Okay, and that's going to give me n equals, because these will cancel out. So let's see, 4 over radical 3. Alright, so that's 4 over radical 3. So that's 4 radical 3 over 3. Interesting. Okay, so that's n that we just found. Alright, but you see n was the short leg. So that's what we just found. We just found n. We just found the short leg right there. Okay, so I'm going to take it and put it over there. So we just found that this was 4 radical 3 over 3. That's the short leg. So by the way, that's y right there. We just found y. But anyway, the hypotenuse here is double n. Alright, so this is n. So I'm going to double it for the hypotenuse. So if I double this, so that's going to be 2 times 4 radical 3 over 3. I can just do that in my head because 2 times 4 is 8. Okay, so this is going to make 8 radical 3 over 3. Okay, because I'm doing 2 times n. So that's 2 times 4 radical 3 over 3. So that's 8 radical 3. So that's your hypotenuse. So that's x right there. Okay. Also, you could take this 4 radical 3 over 3 and go times 2. Okay, and that'll give you 8 radical 3 over 3. So bottom line it. Alright, I'm just going to change colors for a final answer here. We're supposed to find x and y. X was equal to 8 radical 3 over 3. And y was equal to 4 radical 3 over 3. Okay, so that one wasn't quite so simple. Alright, so really study that one, because I have a feeling that if there's one problem on the test that you get wrong, that'll be it. That'll be the one that like a bunch of people get wrong. And it's pretty much guaranteed to be on the test. So don't just, please don't just copy that one down and move on. Come back to it, take out a sheet of scratch paper, and redo the problem by yourself. See if you can get it in like an hour from now, a couple hours from now. Okay, let's move on to B. Yeah, and this is number, by the way, number 15, B. Okay, well this is looking a little ugly, but it shouldn't be too bad, because 45, 45, 90 triangle, these are isosceles. Okay, so if this is 7 radical 2 over 2, guess what? This will be 7 radical 2 over 2. Okay, so we've got that already. Now remember how this works. Okay, for a 45, 45 triangle. Well, that's not what I meant to do. First of all, if you have one 45-degree angle, both angles are 45 degrees. Now, remember the way it works. If this was 7, then this would be 7, and this would be 7. And I'm just going to change the colors for a second. Radical 2. So 7, 7, 7 radical 2. Notice how these three things are the same. 7, 7, 7. Just the hypotenuse has the extra radical 2 on it. So I could erase this and put whatever I want. Okay, so for example, if this was, let's say, 13, okay, this would be 13, and this would be 13, and this would be 13 radical 2. So it doesn't matter what I put here, it'll be the same here, here, and here. Okay, so now we have something a little bit crazy looking, but it still should work the same way. And the crazy looking thing is 7 radical 2 over 2. Okay, so it'll be 7 radical 2 over 2 here. It'll be 7 radical 2 over 2 here. And it'll also be 7 radical 2 over 2 right here. Okay, 7 radical 2 over 2. But I've got this extra radical 2 here. So it's all, this thing shows up in all three places. 7 radical 2 over 2, 7 radical 2 over 2, and 7 radical 2 over 2 radical 2. Alright? Now, you should be able to do this in your head. I have taught you in the past that a radical times itself. Okay, radical 2 times radical 2 is just 2. Okay, it's just 2. So you could do it this way and discover quickly that this is going to be just 7 times 2. I really wanted to use that same orange color. Let me try that one more time. It's just going to be 7 times 2 over 2. Okay, because these two just became that orange 2 right there. And then look, these 2's are actually going to cancel out. So that will actually just leave you with 7. Okay, so the hypotenuse would simply be 7. Okay, so that means this u right here is going to be 7. So u will be 7 and v will be 7 radical 2 over 2. Okay, now if you forgot about the fact that radical 2 times radical 2 is just a 2 and they could cancel out and make 7, let's say if you forgot about that. You could just put the whole thing in your calculator if you want. Okay, you could take this whole thing and put it in your calculator. 7 radical 2 over 2 times radical 2. Watch this. Okay, so I have 7 radical 2 over 2. Wait a minute. And then times the extra radical 2. And you see you get 7 right there. Okay, so either way you're going to get 7, and that's the answer. Okay, so just write that down nice and separate somewhere. Let me change colors for a second. So u is 7, v is 7 radical 2 over 2. Alright, so that's a nice challenging problem as well. Alright, takes a little bit of thought. Okay, so that was number 15, A and B. Okay, now how about C? Okay, so once again, these are the challenging ones. Alright, because it goes n, and then it goes n radical 2, right? So we're expecting this hypotenuse to be something with a radical 2, n radical 2. Normally I say x radical 2, but I already have x over there. Actually, you know what? That would still work out okay. I'm just going to stick with x, because x is in the right spot to be an x anyway. So if this is x, then this should also be x, and this should be x radical 2. So we can divide by radical 2 to figure out what x is. Alright, and that's exactly what I'm going to do. Divide by radical 2. Okay, so if I do 10 divided by radical 2, okay, so 10 divided by radical 2. That gives me 5 radical 2. Okay, so that tells me that x is 5 radical 2. Okay, that's these guys over here. Alright, so that means x is 5 radical 2, which means y is also 5 radical 2. It's isosceles. Okay, so that's it. Alright, x equals 5 radical 2, y equals 5 radical 2. Okay, I think there's one more of these. D. Okay, back to your 30, 60, 90 triangle again. Alright, this one's actually back to easiness again. If this is 30 degrees, this is 60 degrees. They're complementary. But this is the long leg, and we are expecting the long leg to be the short leg times radical 3. Okay, so remember it went x, 2x, and x radical 3. Well, looking at the comparison here, that means the short leg must be 2, alright? Because that 2 is in that X position. So the short leg must be 2. So that means this over here must be 2. Okay, so X is 2. Alright, so if X is 2, that means this right here is 2. Okay, and if X is 2, that makes this 2 times 2, which is 4. Alright, so A is 4 and B is 2. Alright, so flipping it around now that we have it, let's look at it forwards again. Short leg is 2, the hypotenuse should be double that, which is 4, and the long leg should be the short leg radical 2. So the long leg should be the short leg times radical 3, so 2 radical 3. So everything checks out. Alright, this video is getting a little long. Alright, for this last little concept, remember complementary angles. Angles that add up to 90 degrees. The two acute angles of a right triangle are complementary. So, for example, if this angle is 30, you know the other one's going to be 60. They have to add up to 90 degrees. If this angle is 50, the other one will be 40, because 50 plus 40 is 90 degrees. Now, we learned a special theorem involving sine and cosine, and it was that the sine of one angle in a right triangle will equal the cosine of the other angle. So sine of 50, for example, will equal the cosine of 40. Alright, so let's see, let's say if this was 35 degrees, then this would be 55 degrees. Okay, so I could say the cosine of 35 degrees will equal the sine of 55 degrees. Okay, so again, the cosine of one angle will equal the sine of the other angle. Alright, so let's see how far that gets us right there. So they're saying the sine of 50 is this. Then what does the cosine of 40 equal? Well, we were just saying the sine of 50 should equal the cosine of 40. Okay, because those are complementary angles. Let me put that back again. Oh, it's still right there. That's funny. I didn't know it ahead of time. Is it even the right sine? It's even the sine. Okay, so we were saying if this is 50, then this will be 40, because they are that adds up to 90. So the sine of 50 should equal the cosine of 40. So if they're telling me that the sine of 50 is 0.7660, okay, 0.7660, then that should also equal the cosine of 40. Whoops. Even if I didn't have a calculator. Even if I didn't have a calculator, I should know that. Okay, so yeah, so that makes this really easy. What does cosine of 40 equal? 0.7660. Okay, now find an angle that makes this equation true. Well, the cosine of one angle equals the sine of the other angle. Okay, we're looking for x. Not the whole thing with sine and everything. We're not recopying this entire equation. A lot of kids do that for some reason. We're just finding x, the thing that goes right here in this x position. So the cosine of one angle will equal the sine of this other angle. So the one angle is 43. So what we're saying is okay, if the one angle is 43, okay, what's the other angle going to be? Okay, the other angle must be 47. Okay, because together that makes 90. So, alright, cosine of 43, alright, so the cosine of 43 should equal the sine of 47. Okay, cosine of 43 should equal the sine of 47. Cosine of one angle equals the sine of the other angle. Okay, so we're talking this must be 47. Alright, in other words though, where I'm saying x equals 47. That's the answer to the question. Alright, please don't write down the whole thing. Don't write down cosine 43 equals sine 47. I'm not asking you for this whole expression. Don't do that. Okay, I just wanted to know what's x. X is 47. Alright, and number 17, that was the last problem in this lesson. I hope this video has been helpful to you. Alright, please make sure you can do each and every one of these problems by yourself. Okay, go back and repeat. Rinse and repeat, people. I will see you on the next video.